there. So you only have one, so you don't have to collect all of them on one side. All right, bring that up a little. Okay, now your third step is pretty much you want to solve for your dy dx. Okay, so let me just go ahead and rewrite it. 8y to the 7th times dy dx equals 0. If we subtract 9x to the 8th from both sides, okay, that cancels out. Bring that up a little. And that leaves us with 8y to the 7th times dy dx equals, kind of separate that, negative 9x to the 8th. Okay. So now we just divide by 8y to the 7th. Okay. Those two cancel out. So we end up with dy dx equals negative 9x to the 8th over 8y to the 7th. All right, any questions on that one? All right, leave that up for a few seconds. All right. Okay, so let's say, for example, if we had to find dy dx where y is a function of x implicitly, clean up that a little bit, by x squared minus x minus 2 equals 2y squared minus 2y. Okay, so for this, remember your first step, you're going to differentiate both sides. Okay, so the derivative of x squared minus your derivative of x minus your derivative of 2 equals your derivative of 2y squared minus your derivative with respect to x of 2y. Okay, so that's going to give us derivative of x squared with respect to x is just 2x. Okay, minus the derivative of x with respect to x is just 1. And derivative of a constant is just 0, so that actually disappears. You can put 0 there if you like, but you don't have to. Okay, equals derivative of 2y squared with respect to x. We're going to bring down our 2, which would make that 4y, times the derivative of whatever y is. Okay, minus derivative of 2y, that's just going to be 2 times dy dx. So if you notice, everywhere you had a y term, that's where that dy dx pop up. Okay, so you're just going to use the power rule, not the power rule, the power rule, yeah, that was the right name. Use the power rule for it and just dy dx right next to it. All right, so here your actual second step you can skip because they're all on one side. So now you can just factor it. since they're both on one side, you can just factor dy dx out of both of them.
What you're trying to get on one side is the dy dx.
Exactly. So every term, so if you had a dy dx term over here, you would either add or subtract it to bring it over here, because you want all of them on one side. Okay? And the reason why is the third step. If you have 2x minus 1 equals, if you factor dy dx out of both of those, you have 4y minus 2. Okay. And then you could just divide both sides by 4y minus 2. Okay, so those two cancel out. And you end up with dy dx equals 2x minus 1 over 4y minus 2. We'll clean that y up a little bit. There we go. Oh, and that would be your, why did I do that? And that would be your final answer. All right, any questions on that one? All right, leave that up for a few seconds. All right. Okay, so let's see if we have the example. We'll find dy dx. Where y is a function of x implicitly by y squared minus 3x to the third y to the fourth equals 1. Okay, so the first thing you want to do is differentiate both sides. So you have the derivative with respect to x of y squared minus the derivative with respect to x of 3x to the third y to the fourth equals the derivative with respect to x of 1. Okay, so here, derivative of y squared with respect to x. So you're going to bring down your 2 to the front. And that's times your dy dx. Minus, and here you're going to have to use the product rule. Okay, so you have your first, which will make that 3x to the third, times the derivative of the second, plus the second, times the derivative of the first. So times the derivative of 3x to the third. Okay, equals, derivative of a constant is just 0. Okay, so if we have our 2y dy dx minus, well, we can go ahead and just distribute that if we wanted to, but I'll leave it till the next step. 3x to the third times the derivative of y to the fourth with respect to x. Bring down your 4. and you subtract 1 times your dy dx. Okay, plus y to the fourth, derivative of 3x to the third with respect to x, since they're both x functions. You just bring down your 3, which makes that 9, and subtract 1 from it, equals 0. Okay. So that means we have 2y times dy dx. And if we go ahead and distribute our negative, minus, and we can go ahead and make that 3 times 4, which is 12, x to the third, y to the third, times dy dx, minus 9x squared y to the fourth, equals 0. Okay. So now this one, we have some dy dx terms and other terms without dy dx. So we want to get all the ones without dy dx on the other side, which means we have to move this one. Okay, so let me rewrite that. Dy dx minus 12x to the third, y to the cube, times dy dx. If we add that to both sides, that's going to equal 9x squared y to the fourth.
Sorry, I'm still writing it down. What exactly cancels out the dy dx pertaining to 9x squared?
Oh, because they're both functions of x. So just like we've been doing so far.
Right, okay.
All right. Now, once we have just the dy dx terms on one side, just like we did before, we're just going to factor it out. And this one, make a little side note. So this particular term, we just move to the other side. Okay, so if we factor out our dy dx, that leaves us with 2y minus 12x to the third, y to the third. Okay, that equals 9x squared y to the fourth. Okay, so now if we just divide both sides by 2y minus 12 x to the third y to the fourth, x to the third y to the third, sorry. These two cancel out. So your dy dx equals 9x squared y to the fourth. If you want, you can factor out a 2. You don't have to. 2y minus 12x to the third y to the third. All right. Any questions on that one? All right. Okay, so what if we wanted to find the second derivative? That's denoted by that, where y is defined implicitly by negative 3x to the fourth plus y to the fourth equals 4. Okay, so first we differentiate all the terms. So derivative with respect to x of negative 3x to the fourth plus derivative with respect to x of y to the fourth equals derivative with respect to x of 4. Okay, so since this is a function of x, we just have to bring down our 4. So that gives us negative 12. And we subtract 1 from the exponent. Plus derivative of y to the fourth with respect to x. Just bring down our 4. So we have 4y to the third times dy dx. And derivative of a constant is just 0. Okay, so if we just get our dy dx to one side, which that's the only one, we just add 12x to the third to both sides. And that gives us 4y to the third times dy dx equals 12x to the third. So if we divide both sides by 4y to the third, okay, these two become 1, that cancels out. So we have our dy dx equals 12x to the third, or 4x to the third, or 4y, thank you. 4y to the third, which means our dy dx is equal to 3x to the third over y to the third. Once we simplify our 12 and 4. Okay, so we're actually going to have to come back to that, so that's why I drew a little square around it. Okay, now our second derivative is just the derivative of our first derivative. Okay, which means you want to find the derivative of 3x to the third over y to the third, which means we have to use the quotient rule. Okay, which means you have our denominator. Let's clean that 3 up a little. Times the derivative of our numerator minus our numerator times the derivative of our denominator all over our denominator squared. Yes.
Question on that.
Mhm.
On a lot of the homework questions that I was doing using the quotient rule,
Mhm.
it kept marking them wrong when I wrote it out exactly
Yeah, I was
like
gonna
that.
ask that too.
It was switching my terms.
Yeah, even when I looked it up online,
Mhm.
I had the product and the quotient rule was differently.
Yeah,
Like, it
so
would-
instead of being like the lower times the derivative of the high,
Mhm.
they put derivative of high times the lower minus.
But they put the first one minus?
What do you mean?
Did they make it the...
Well, just take that, so
Mhm.
like on the homework, it would be d over dx 3x cubed times y third. And if you didn't write it that way, you'd get it wrong.
Really?
And it's making
Mhm.
very, very, very long homework assignments.
Oh,
And that's not right,
yeah.
because there's that mnemonic, like low D high, high D
Mhm.
low over low squared,
Mhm.
and that's what I was following, and
Yeah.
I don't know, and it just seems like the
You mean
quotient
if
rule
you
section that was
if you put
working,
these switched, it would mark it wrong?
if I put it just like that, it
Mhm.
would mark it wrong. It
Really?
wants it to be switched.
In the examples, it was like putting, when you would follow,
Mhm.
I have it written down somewhere too, it was putting like, it was switching the F derivatives and the G derivatives. It would
Mhm.
have like the G.
Really? Hmm.
I didn't have that problem.
Hmm.
And we haven't finished it
It was
Mhm.
doing that on the product rule for me too.
Wow. Because I know on the
It's
product rule,
only-
they
it's-
sometimes switch
Well, the
them up.
product rule doesn't matter, because you're
Yeah.
just multiplying and adding, so you
Yeah.
can put it any which way and you're still gonna get the same answer. But if you're doing a homework assignment
Mhm.
for quotient and product rule,
Mhm.
it writes it like that. But every section after that doesn't work. So like even when I was doing the trig functions, like what we were doing like last week,
Mhm.
by not having the trig function first, times that, basically the opposite of what it should be, it would be marking it wrong.
Yeah, I was marking mine wrong too, and it wanted me to put it F prime, G, and then minus this F and then G prime. If I didn't do it that way, it was marking it wrong. I was super confused, because,
I think I have one
Yeah.
saved.
yet.
I
That's
don't
the
see
right
it.
way.
okay, well, he's not doing it that way, then this one.
Yeah, I don't know why they're doing that one. You can write down the number problem or write down the problem and let me know which one it's acting up
I think
for.
I have it saved.
Oh, okay. Hmm. All right, let me finish up this and I'll look at it. I'll try to get done early enough to look at it after class.
Okay.
All right, but yeah, I don't know why they're doing that one. All right, so if we finish up this one, say y to the third, the derivative of 3x to the third, just bring down our 3, which makes that 9, and subtract 1 from that exponent, minus 3x to the third, derivative of y to the third with respect to x, we bring down our 3, and subtract 1, times dy dx. All over y to the third squared, which is y to the 6th. Okay. Now the reason we drew that there, or that little square, is because we can just replace that. Since that's our dy dx. All right, so that's going to give us 9x squared y to the third minus 3x to the third. You can make that 9x to the third y squared times 3x to the third over y to the third. All over y to the 6th. Okay. Now these two actually cancel out a square, which just leaves that to the first power.